Good morning, everybody. My name is Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation. And today we're doing something a little bit different in that I'm joined by Max Kleinsorg from the marketing team. And we're covering basic FIWARE terminology. Now, there's a reason behind this, and there's a sort of dichotomy within the FIWARE Foundation itself. If you look at the FIWARE mission statement, you can see that the FIWARE Foundation, not for profit, so we're not making money out of you, driving the definition and encouraging the adoption of open standards. Now, this very much splits two ways. I'm very much doing the technical standard stuff. I'm the technical evangelist, whereas Max, I'm just going to give him a wave, Max. Max is all to do with how can we get this to other people, how we can get this information out, because there's no point in having a standard if no one's using it. There has to be a way forward and understanding, and this is where the problem lies, because I don't understand marketing, and technical people find it difficult to marketing people find it difficult to market a technical interface, and we need to come together and build on both our strengths in order to understand what's actually going on. So the idea here is that we'll cover the sort of questions which Max gets asked at various events, fairs and what have you, and then discuss the understandable and meaningful level. Developers, there are, again, this is all information for the FIWARE website. What is FIWARE? Well, FIWARE is a smart solution to gather context information, and that context information is the state of the now. What are things? Are things happy? Are they hot? Are they cold? What's happening in the world? Basically, you need to ask three fundamental questions for any entity in the real world. One of them is, who are you? In other words, you have an ID and you have a type, and this is unique for that particular class of object. Where are you is another one. So location is well defined, and you can do things like geofencing and work out what's going on within a specific area. But the third part, which is more vague and will depend very much on your own use case, is how are you feeling today? It's not necessarily the case that every system has got the same attributes. If you're talking about smart agriculture, it's completely different to being in a smart city. However, the nice thing about FIWARE is that because we have standardized an interface, and Max will be describing that in a second, it doesn't matter, because we are just interested in the context data itself. Now, central to any smart system is a so-called context broker. And again, you can see this, the diagram on the right, there's a loop. You retrieve information from the real world, work out what's going on, and then actuate. You make changes to the real world somehow to cause an event to occur to change the case. So, for example, if you have a soil sensor, the soil is dry, and then you put that, take that to Context Broker. Context Broker passes that up to processing element. Say, oh, I better switch on my water sprinkler. That will actuate the water sprinkler, and it will then make the soil damper, and then so on and so forth. In fact, if you, I was actually looking at a system based in France yesterday, doing rugby fields, and that's precisely how it works. Fundamentally, they use the context data where you get the information from the system. But context data is not just sensors. In this particular case, they were saying, okay, when are the matches scheduled? Well, that's coming from the city department. Well, we don't want to turn on the water sprinkler in the middle of a match, so they need to take the whole of the end-to-end context, the whole world, understand the whole world. The better you can understand that, the more you can do make intelligent decisions, like not raining on the rugby players, and then go off and see what's going on. Now, interfaces. Okay, we are marketing a technical interface. So what's an interface, Max?
Well, first of all, as you said, I'm from the marketing team, and I'm sure most of you know our Smart World by FIWARE, which we built entirely by Lego bricks. You can see it in the picture here on the left. And yes, in the end, playing with Lego bricks means having an interoperable interface. So if I play with Lego bricks and you play with Lego bricks, Jason, we can also play together with Lego bricks because they are all same together, or all have the same interface. We can put one stone on the other and build something together, or each of us can build its own solution, his own solution, and then pass it over to the other, and he can build with it something else or work on it and maybe change it a little, but it's always
now that opens a lot of things with FIWARE, because again, you can see on the right, we effectively have three major layers of architecture, three major interfaces for our bricks. But you're not, when you play Lego, you're not defined, you must build a car. You could build an aeroplane, you can build a house, you can build whatever you like, build a robot. So it's not constrained by domain. For a start, you can say I can build whatever I like, but also you can obtain IoT, in our case, IoT devices from one company and plug them into a context broker from another company and plug in a processing module from a third company, and they will all work together because the interfaces are well defined. Now, the layer on the right is data management, publication, and monetization. This is things like security. You need to have security in your system. And this is more along the lines of we follow other standards, because FIWARE doesn't mandate you must use this security, you must use that security. We're flexible. We are we're open to innovation here. And the point being that you can plug in whatever you like on your software, you can plug in whatever you like on your Lego. And it's because we have this well-defined interface. Well, how are interfaces defined? They're defined by standards. So back to Lego.
Yeah, right. Still, Lego has patents, so that's maybe a little difference, but the patent from Lego was defined already in 1940, and they are really keen on it. So you better don't build your own Lego bricks at home and try to sell them, because you can be pretty sure that Lego sues you for that. But of course, if you follow this patent, you can be sure that the Lego brick you have will fit together with the Lego bricks out there. But what's the difference to Etsy specifications, for example?
Well, Etsy specification you can freely download from the internet. We are what's known as an open standard, which means that we offer this interface for anyone to use at no price, and anyone can do the interface. This is the whole point, is that unlike Lego, who are making a big business out of their patents. Actually, I think the patents have now expired because it's so old, but they used to have exclusive use, or you would have to pay a license fee. There's none of this license fee business with FIWARE. And the problem with the Etsy specification is that because it is a software specification, it is exceedingly dry. It needs to be very technical. I mean, okay, you can see the numbers on the Lego patent, and you can understand what's going on. But what needs to be done is that the software is the interface is described in excruciating detail, so that completely separate companies can connect together. And of course, my job is to read these dry specification, or influence this dry specification, and make it understandable. So if you look at the FIWARE tutorials, they will slowly walk you through how to start with FIWARE, how to get the data into the system, how to get it out, and then slowly build it up so that you end up with, say, adding another FIWARE component. You'd end up getting a dashboard working, and so on and so forth. And it slowly builds up a very simple but complete system. Now, obviously, no one is going to have a real system of 4 cows wandering around one field. However, you use those principles with whatever system you've got, like the playing fields example I gave earlier, to expand it and actually use the context which is relevant to your use case. As I said, we're not stuck with doing just, I don't know, just sensors. We do, the whole range from smart tourism to industry, because there's context in every single system. Okay, so you've probably seen this in fact, on the very first slide. You'll see this like open APIs for open minds. Well, an API is the definition of the software interface. It's how you ensure that one piece of software talks to another piece of software, and it's open if there's no license fee involved, and as I said, anyone can use it. Now, Max, why should companies and cities use open APIs?
Well, in the end, there's a lot of reasons, but especially, I think building an open environment in data, but also in all kinds of city environment, but also all the connected domains where FIWARE is active in, it makes it easier to build new business cases, but also make the city or the whole data more transparent for its citizens and third parties. So I think, for example, if you want to build your own mobility platform, you will probably need different kinds of data, which you will also explain later on. But to really make this happen, you need different open APIs to connect the different kinds of data.
Of course, the other thing is that you may find you can try before you buy, really, as well. Another thing is you can trial stuff, because you're not stuck with once you made the decision, I want to use, I don't know, Orion as my context broker, and then you say, well, actually, no, maybe I should use Stelio, or maybe Scorpio is the one I want to go for. You can switch these things out in and out very, very easily, because they are open. They are able to interconnect. Or if you've got a company which is wanting to join your system, well, you've already got a well-defined interface for them to be able to plug into. Now, open is one of these words which gets overused massively in software, and it's a bit of a buzzword. But you can see that another example where it's used consistently is with open data, and this is particularly a case with smart cities, where cities are offering all the information they've got within the system, like, as I said, for the timing of people booking football fields, so that it can be used by other applications, other citizens. The more that you can interconnect the data you've got, the better you've got understanding of the real world, and the better you can understand how I should do what and when. Now, again, open data, it's going to be open through various standardization, and it's going to be available in a format which is going to be understandable by your system. Open source is the software. This is the difference between, say, the components in FIWARE and, say, I don't know, Microsoft, in that you will find all of the software which we promote within the FIWARE catalog on GitHub. Which means you can look at the code, you can find bugs in the code, you can make change requests to the code, you can improve it, and if necessary, you could fork the thing and make changes as necessary. Open source means that it's the phrase which we used to use in one of our things, which free for all forever. Because there's no way in which you can make the open source stuff we've got private. It has to be open, and we're all talking about flowing between the various components. Now, obviously, the members of the FIWARE Foundation are companies which are making money, but you can make money out of your components outside of this small set of generic enablers. And again, we've got this FIWARE marketplace where, I'm selling devices. Well, I'm selling devices for money, but they have this standard interface so they can plug into your city or his city or her city or whatever. And you can see how the various different elements you might have, people who want to do, say, infrastructure, or we're selling infrastructure services, or I've got a particularly clever algorithm for working out AI or whatever. And that's the proprietary stuff. It's the interface which remains open, and it's there are various elements which are common building blocks which you might want to use for other bits and pieces, which you might as well steal for free, because why not? But does open mean free?
Well, that's a question we got asked a lot at fairs, for example, because yeah, often people think it does exactly mean that, but it means more like free as in speech, but not free as in beer. So you can use it at no costs, yes, but there might be restrictions. For example, giving credit to the original writer of the code, or contributing back, or yeah, simply saying where you get the code from. So yes, there often you can use at least codes or parts of it at no cost. But as you also said, sometimes if you get solutions from our marketplace, you also have to pay for a product. But still, it still means it's made by open source.
Yeah, I mean, the classic example of restrictions to freedom is you can't shout fire in a theatre. You're free to say whatever you like, but there are certain situations where actually there are certain restrictions. And so, for example, if you are using, say, the Scorpio broker has got a BSD clause 4 license. You can't use NEC's name in your advertising. So you can't say, I've got a wonderful smart city solution and it's powered by NEC's Scorpio broker. They won't. That is one of the things which their license specifically denies. There's another YouTube video which we've got on licensing of FIWARE components. They go from the more permissive, which tend to be, well, anything which the FIWARE Foundation creates is usually MIT. It's basically just saying, just mention FIWARE Foundation, use it as you like, certainly for the tutorials, through to strong copyleft licensing, which is saying, okay, this is free, but we want to make sure that it maintains free, so that if you want to make any improvements, please contribute back to the main branch of the software. It's all free. There's no underlying cost. There are underlying obligations. That's the important difference between the two. So, role of the FIWARE Foundation. The FIWARE Foundation, this is something which I get asked sometimes, is that, in fact, this is one of the questions I usually ask when I'm giving job interviews, for that matter. The FIWARE Foundation is a promoter and referee, but not a participant. Imagine we're in a boxing match. We're the referee in the middle, and the two boxers are, say, engineering and Telefonica, who may have competing systems doing the same thing, but they worked out that actually, it's better for both of them to be able to sell their preferred solution, say in their market, or be able to connect a Telefonica system to an engineering system, or whatever. It's not the case that the FIWARE Foundation has got lots of engineers, or indeed a particularly large marketing team. We are deliberately small. We're funded by our membership, and the whole point here is that I'm not in the pay of Telefonica. I'm not a Telefonica representative. I'm not in the pay of engineering. I am representing everybody, from our platinum members, gold members, individual members, trying to make sure that everybody got a chance to get a slice of the pie. And this is how open APIs can nicely keep open to it for innovation. If you look at the sport of high jumping, for example, famously Dick Fosbury is the innovative fellow who started jumping backwards over the bar and massively increase the heights which you could actually jump. Same sort of thing here. Because this is an open API, someone small and agile, a small SME in a particular niche area, is able to get a small slice of the pie relevant to their use case, and fit into the system. This is actually one of the reasons why FIWARE was born in the first place. It's all about making sure that there is open competition. Now, the difference here between, say, the rules which were happening in high jump and Formula One is the case that no matter how fast or good Max or I are at driving, he's actually better at sailing, I know that, there's no way we would be able to become Formula One drivers, because that is a closed organization. They say we have a certain number of slots. and you pay a certain amount to get in each year, and it's a cartel effectively. It's closed within the actual system. So you can see that we're here as a way, a means of lubricating the system to make sure that everybody's got a chance, rather than there's one particular dominant player within the context. Okay, so now on to some technical terms. This is the one slide I tend to use for the developers in a hurry. Usually you get lots and lots of slides, but this is saying this is what FIWARE is. I said it's context data management for smart solutions, and it's these 5 points. It's REST done right, standard mapping of HTTP verbs and status codes, JSON payloads, and some additional structure rules, registration to augment context, and a publish subscribe mechanism. And developers go, wow, that's great. And then non-developers go, what? What's that? So what do we mean by these various different terms? Well, what is REST? REST is a well-defined mechanism for passing data through the system. It's stateless. So classic example of a REST system, which is formally defined by a guy called Roy Fielding, is the internet. Whenever you get a web page, you're making a REST request and saying, give me this resource. And then it will give you everything about that resource. But you can then do things like you can follow links, which is technically called HTTPS on the element. So you can navigate from one system to another. If you've got something /entities, it will give you all the entities in the system. If you go /entities and an ID, it will give you that particular element. So this is a case of not surprising the developer. These are systems which are already out there, and there are tools which will help create your system. So an example I use is Postman, which will actually write large chunks of the code for you. If you want to make a REST request or change it or whatever, you can actually press a button, it will generate some code, and then you can just paste that in, and you know it's going to be quality code. This is one of the boring boilerplate sort of jobs, which you just need, you just say, well, I don't need to write that from scratch. I can just get it done straight away. Developers are basically lazy. The other symbol there is something called well, it's usually called Swagger, but they're given the name Open API these days, which is a bit silly. That is defining the payloads, the actual data which you've got within the system. And of course, again, I don't want to have to make things broad or do too much work. Press a button, it will generate stubs for you. It will generate the code for you. It's all about trying to make life easier for the developer. And this is all a standard way of doing stuff. And this is why developers enjoy using a well-defined REST API. Now, I say well-defined. There are plenty of APIs I've seen which claim to be REST, but they're actually just using HTTP as a transport mechanism. They don't understand the rules. Whereas if you look at the original Fielding thesis and actually look at what you're supposed to be doing, it makes it so much easier for everybody else. Fundamentally, we don't care what the underlying protocol is. If I'm connected to devices which are, say, using OPC UA, let's say, I don't need to do that. I just need to do an HTTP call, which is that REST interface, the one which we're defining by FIWARE. All the rest of this stuff at the bottom of the IoT devices is abstracted away into other components like the IoT agents. So if you just do a simple REST request like that, you can see it looks like a URL you might type into your browser. You can get the values of a element within the system. That's going to get the value of the present sensor on lamp 1. It's an NGSI v2 request. And it just gets hold of the connectivity, just reads the value, which simplifies everything. And then if someone else changes to a different system, let's say, I know it's based on ultralight or whatever, or Sigfox, doesn't matter. It's still going to be within the context broker in the same fashion. So all the developer needs to care about is sending an HTTP request where they've already got the code generated for them. Well, it can't get much simpler than that now, can it?
Probably not, no.
Now, the payload for this is something called JSON, which obviously confuses me. But it's JSON is it's JavaScript notation, and you can see, and I've got an example on the right, that the format is basically human readable. I mean, you could understand if you read those words on the screen, you can see, yeah, this is probably a building, and it's got 7 floors, and it's open from Monday to Friday, and shorter hours on Saturday and Sunday. You can, when you're debugging a system, it's important to be able to look at the stuff and be able to see what's actually going in. Now, this is not a full NGSI. This is just a key value pairs format. It's one of the formats which you can get out of context brokers. But the important thing here is that JSON is therefore an ideal language for data interchange, because there are plenty of parsers out there. All this stuff can be done automatically by someone else. It's you're either going to use JSON or XML. We're using JSON. It tends to be younger developers who prefer to use JSON. Older developers used to be enterprises more XML based, but you're going to go for one standard or the other. Now, we can extend this from JSON to JSON-LD just by adding in an additional element. And this is this at context thing. This is actually quite tricky. If you look at the list of elements here, you can see we've got name, born, and spouse. But what really is a name? In order for a computer to understand it, you can't just rely on 4 characters, N-A-M-E, to well-define things. I might know several people called Max. Yeah. I need to be able to differentiate between Max A and Max B. So you'd use a lot of full name, and these are again usually like those strings you type into your browser. But you don't want to put that into your payload, because this is actually, you can read this, and you can, so it's all pushed into this additional file called an at context file to define what the full long names. It's basically a dictionary of full long names of what the various elements are. So I can do things like saying, well, that address, it's actually an address in the format from, say, schema.org. So the computer would know that it's got various sub-elements in it. And then there could be another set of data where they're saying, well, that address, it's actually got the elements from the TM forum address, which we know is 99% similar to the schema.org one. So we can actually do manipulation of the data from additional outside sources to be able to get the system in. Now, NGSI is this REST API, but it's based on JSON, and NGSI-LD is based on JSON-LD. So you'd use NGSI v2, the older format, if you're not doing data exchange between wide areas. You'd use NGSI v2 as LD if you're looking to do data sharing, things like that. Now, the difference between a JSON payload and an NGSI payload, as you can see if you look carefully here, is that we've now got every attribute, like the name, the born, and the spouse, has got a type and a value. It's just a little bit more structure. Technically, what NGSI is it's an extended subset of the of JSON. So not only have you got that format, you've got a little bit more structure in there, and that little bit more structure is sufficient for us to be able to extract meaning And there's these things like properties and relationships, properties being, what's going on, and relationships being links between one entity and another. And the important point here is that this is still valid JSON-LD, even though it's NGSI-LD. Every NGSI-LD payload is valid JSON-LD. So we're building on other people's work. We're standing on the shoulders of giants, basically.
Okay, so if I get this right, for example, to come back to my example with the mobility platform in a city, I have all kinds of different kinds of mobility, like scooter sharing, bike sharing, car sharing, public transport, and all these data are supposed to be in one platform. So that's where I would need NGSI linked data to really make this happen. So
yes,
everyone.
That is precisely the case, because you can't dictate that, I don't know, a French scooter company is using precisely the same terms and names as an Italian scooter company.
Okay, right.
Because fundamentally, organizations tend to follow their own style, their own rules, and we can then use, but if we can agree what the long names are, and this is the basis of data models, if we can agree what the long names are, it doesn't matter what you're using locally, internally within your software. Internally within your software, you do it your way, fine. Internally within my software, I'll do it my way, fine. But we are agreeing across the long names so that it's interoperable between the two. An example I give in the tutorials is I have buildings written with attribute names in English, and I have other buildings with where the names are all in Japanese. Now, I don't speak Japanese, but because we map both of these characters to the same long name, you can read in using one and write write in using one and read in into the other one. It's perfectly understandable. So this is all, again, fundamentally to do with interoperable. That's the reason why you need to go through the hassle, and it is a hassle, of dealing with linked data. But linked data, when it's used properly, is very powerful. If you've ever gone onto a search engine and you've looked for, I don't know, sailboats, probably in your case, and you can see a star rating and a price at the top. Well, that's not because Google knows what the price is. It's because the manufacturer has put the information onto their web page using linked data in a fashion that the search engine can understand, and the search engine can then manipulate it and display it on screen in a understandable. Because obviously, although these search engine companies are big, they don't own every single website in the world, but the machines can understand them, and that's the key.
Okay, you just mentioned data models. So we at FIWARE have the Smart Data Models program to de facto standardize data models. Where do they come into this whole story?
Well, you need to have this dictionary between your short names and your long names. Now, there's fundamentally a problem trying to maintain data models, in that it's hassle, it's work. I don't want to do that. So you're much better picking the stuff which people have got already, or contributing something into a public space so that I can reuse your model, you can reuse my model, and we can come to an agreement. Now, if you can find a place where you're able to do this and it's up there, it will then be usable by the next person, and they will have the same structure for, say, a device or a football field or a sailing boat or whatever. It doesn't really matter because it has already been used in a practical project. Chances are it's going to have most of the information you need. You might need to extend it, in which case you just make another contribution and say, well, yeah, I now need this information into that model. But then you've got a well-known long name, IRI, for whatever the element it is. So if you're talking about, say, temperature, I can, and you say temperatura, and I say temperature, or you say heiß or whatever. We can say, we can agree that this is actually one of these things we're talking about. Interoperable, that's the important point there.
Yeah, right.
Now, we don't do everything. We are very much focused on context information management and this interface. That's what we're talking about. However, we build on other standards. There are other areas which are covered by other standards bodies, and we say, if you're going to use security, well, why don't you use OAuth 2 security, because that's one of the standards out there. If you want to get IDs of citizens in cities, well, why don't you use OpenID, because that EIDAS is the European standard for getting users, and you can use OpenID for actually passing that user through the system. So once you've agreed to let out certain bits of information about yourself, it can then be passed between the various different systems. We don't mandate a security system because we're trying to keep this as flexible as possible. It might be the case that you want to have a very secure system which requires a handshake between two boxes before they start talking to each other. That's the case in manufacturing, for example, in which case you probably want to use an IDSA connector. You might want to just do the sort of thing where you can log on using your Facebook account. Well, that's going to be OAuth 2. There's, they're different levels of security, and it's more a case of use one, certainly, but you're not forced to use IDSA if it's not appropriate for your environment. Now, going back to this Swagger Open API, on the smart data models, you will find that there are Swagger definitions, which means that all the models we're talking about, you can generate the code automatically. So this again makes the life of a developer a lot easier if they start using some models which they know other people will be using anyway, and if they're in a position where they want to start sharing the data, they've got a nice little standard which will go forward. So this is building on the works of other organisations which are orthogonal to what we're doing, but obviously important that when you're going forward that you can talk in a common fashion. Now, we'd actually move onto data sharing. There are lots and lots of acronyms which go on about data sharing. So CCAN, DCAN, these are data sharing. Do you want to tell us a bit about Gaia-X, perhaps?
Yeah, right, sure. Gaia-X is the European data project or strategy. It's an association nowadays, and we are proud to be part of it. And yeah, in the end, it is all about building the own European cloud, so that infrastructure data and other data that is important to us or our companies, our citizens, is not in the hands of big private companies, but in European hands. So that's why Gaia-X was founded, and FIWARE is proud to be active in several data spaces. For example, the mobility data space here from Germany, where we have 2 of the 16 pilot projects. And yes, I think it's an important step to really make it possible to really have an open data approach in Europe. And yeah, as FIWARE is European-wide active, I think it's quite good that we're in there.
Of course, it makes sense to use NGSI-LD as your data exchange in that case, because again, it's a matter of using standards out there to use other standards. I mean, the other one which I've got on that slide, Hadoop, is basically a way of building your own data lake, because instead of having a database, it's like having a library of databases, because when you've got a massive amount of data, it starts becoming quite difficult to classify it all. So you need to be able to get information from various different sources to understand the holistic whole of the system, because the whole point about smart solutions is that the more information you've got about the real world, the better you can make your decisions. And if you can make better decisions, you can save money, or you can make interventions earlier to be able to do things better and improve the life of the people involved. So what's next?
Yeah, well, thank you so far for listening to us and all the interesting terminology we just explained. If you want to read on, we have a lot of marketing material. You can find it on the FIWARE.org website. We have a white paper on data spaces where we explain a lot how FIWARE contributes to data spaces and open data or open data platforms. The same thing, also a white paper for digital twins. Digital twins rely on data and data spaces. So this is connected, and you can also find the white paper on our website. We are active in a lot of smart cities already. How we do that, you can read in our smart cities brochure. So there's everything about smart data models, about smart cities, but also our reference architecture, all the cities we are working with. And if you want to have some more...
I frequently get asked that one, and my answer is, I don't know, ask Max.
Yeah, that's right.
The big difference here is that I'm setting up simple, small-scale systems, which are just demonstrating the use of it, whereas what Max is talking about there is actual proper full architectures, cities which are actually already using this stuff in anger. And I know full well, I mean, I'm an experienced enough developer to know that what I'm doing is not the way you would do it directly in a big city. There are other concerns when you need to start scaling and you need to start pushing stuff to the cloud and what have you. And this is the sort of thing where, again, you've got another layer, another level of understanding. Of course, you can talk to the people from either technical or people who've actually got proper installations there to say, hey, does it work for you?
Yeah, sure. I also have a lot of conversations where I then have to say, hey, listen, guys, okay, I can tell you in which cities we are and who is doing what, but if you have technical questions, please ask Jason or his colleagues. But yeah, I think we are proud at FIWARE to that we now can say we are in roughly 250 cities worldwide, which is already quite a lot. And if you want to have some more hands-on examples how our community is doing that in different cities around the world, we have the FIWARE for Cities booklet. At the moment, we have 62 cities from 18 countries in there, which is already a lot. But until our global summit in January on Gran Canaria, we will make it a book with all the cities in there and 100 examples how to use FIWARE in smart cities. And finally, we talked also about the Smart Data Models program, which FIWARE is leading together with IUDX, TM Forum, and Open and Agile Smart Cities Association. And yes, you can find everything about that on the Smart Data Models website, smartdatamodels.org, or also on GitHub. Jason already explained that there are a lot of possibilities to create your own data models or let create. I can say we can now even do it in Italian and Japanese. And yeah, that's it for now, I think. And Jason, maybe you want to do the closing.
So thank you very much for coming today. On top of what Max has said, there's plenty of technical information available on the FIWARE website. We run a regular series of Wednesday webinars. Next week, we'll be talking about FIWARE experts. So we're going from the full range from totally non-technical through to completely technical. We're covering the whole of FIWARE. So thank you very much for attending today. I hope you've learned something and enjoy the rest of your day.
Jason, thank you for having me. And we have one question here in the Q&A, whether you can send emails to us. Of course, you can do. You can find our emails on our website, I think, and also. Yeah, just follow us on Twitter or LinkedIn. Just send us a message there. You can also always write to press.office@fiware.org. I hope that helps. You can find me on LinkedIn. You can find Jason on LinkedIn too. So yeah, just contact us.
Yeah, and we're always ready to answer questions, but don't ask me any marketing questions. Thank you very much.
Thank you, guys.